Okay, we're going to look at global and local winds. So on the next clean page in your journal, you're going to write the heading, Global and Local Winds. Please make sure that you are on a right-hand page. Okay, global and local winds are caused by uneven heating of the earth. You're going to write that down, and then you're going to draw an earth underneath what you wrote down. You don't need to write down this heading wind, okay, but you do need to write caused by uneven heating of the earth. All right, write that down, draw a circle to represent the earth, and then come back. So what happens is the sun comes in, and it's going to hit the equator the most directly. So the equator is going to be hotter than the poles. You notice you've got this slant here for the poles, but here the curvature of the earth isn't quite as much. So the sun is going to hit the equator most directly, therefore it's going to heat this up a lot more than it will heat the earth down by the poles. All right, so the uneven heating of the earth because of the roundness of the earth is where we get wind from, global winds. All right, so you're going to write a little heading that says equator versus the poles. And then you're going to write each of these. The air rises at the equator and heats and heads toward the poles. Okay, so you write that down as one. And then two, the air sinks at the poles and heads to the equator. So if you recall, what we just wrote was that the sun warms the earth right here. It heats that air. That air will rise and it will head towards the poles. Okay, that air rises and heads towards the poles. On the drawing of Earth that you made, you don't need to do a second one, but you can do this drawing on the drawing that you already have. So the air sinks at the poles and heads to the equator. So we have here the sinking air at the poles that's going to head to the equator. Now you notice that we kind of have two different directions going on. So what's going to happen is this air will say, "Hey, wait a minute, I'm getting hot. I'm getting hot. I'm going to head back up." It's not going to get all the way to the equator. And this air is going to say, "Oh my goodness, I'm getting really cold. I'm getting really cold. I'm going to sink and I'm going to head back and get warm again." So what we end up with are what we call Hadley cells. And we're not going to, you don't need to remember that. But we end up having actually 3 on top and 3 on the bottom of these circles. So this air here, remember it's getting all warm, it's getting warm. Oh, I'm hot, I'm hot. Oh, I'm cold, I'm cold, I'm cold. Okay? So these are the global winds. These you don't feel these when you walk outside, but you do feel them. That's the reason that we go here to down here. This is called the tropics. All right, so this is a tropic of Capricorn, and this is the tropic of Cancer. And we'll talk about those tomorrow. All right, how winds are named. So you're going to put another heading. You're still on the same page if you have room. All right, this is a secondary heading. All right, number 1, winds are named by the direction they are coming from. So example is easterly blows from the east, westerly blows from the west, and a sea breeze blows from what? Raise your hand. Raise your hand. Max, you're right, from the sea. Okay, get that written down. That winds are named by the direction they are coming from. So we're going to look at some local winds that you feel when you would go to the beach. All right, so here's a picture here. You don't need to draw anything right now, just watch and listen. All right, this is a sea breeze because we have the breeze. You are standing on the beach right here. Here's Parker standing on the beach. Okay, and he feels the breeze coming from the water. So it's a sea breeze. Well, why is that sea breeze coming? Because this water here, the ocean pretty much stays the same temperature. Okay, it doesn't change. Okay, however, the land reacts quite more to the sun. So, during the day, as the sun warms, the land gets warm. All right, and it will cause the air above it to rise. All right, it rises up, it starts to cool, it gets pushed over, and the cool air comes, it condenses back down, it cools off. We have our area of high pressure here, and so here come the winds blowing, the sea breeze. Now, let's see what happens at nighttime. What's going to happen at night, do you think? All right, at night, the land will cool. Remember, the ocean is still going to stay the same temperature. But relatively, the land cools off quicker. So now, what is warmer? The ocean is warmer. So the air will heat up above the ocean, rises up, goes over towards the land, and now we have what we call a land breeze. Okay, so Anna is here. She's sailing in her boat. Here's little Anna sailing in her boat. And she has a breeze off the land. Of course, it's dark, and so she can't sail. But this is a good demonstration. You're going to want to watch this. We're going to watch this a couple times. I need to make that go away. Okay. So this is a good animation here. Okay, now you see it's noon. It's 12 o'clock. So notice that the land is warm. It's 85 degrees. The ocean is 65 degrees. Watch what happens as the day passes, meaning the sun changes the temperature of the land and the water. Okay, now we have at noon, the land is 20 degrees warmer than the water. Tell me when to pause it when the temperatures are the same. Oh, I missed it. You were too slow. All right, the temperatures were the same. Notice what happens to the wind. What has happened to the wind now that our temperatures are close to being the same? All right, here we go again. We're going to continue. Okay, it's midnight. The land has gotten cool. The ocean is still the same temperature. And now we have the land breezes. And whoops, I missed it again. Okay, we'll play with this a little bit tomorrow. But the point is that we're going to write this down. Where am I? No. All right. Okay, so the point is we have land and sea breezes. All right, the land heats and cools quicker than the sea. right, so that means that air rises from land during the day and air rises from the sea at night. Okay, so those are the three main points. It's all the uneven heating and cooling of the earth. When we don't have the same temperature, something is hotter than something else, and the air rises where it's hotter, and therefore causes high pressure and wind to blow. We will do some looks tomorrow at the different wind bands and the Coriolis effect. Good night. Have a good night.